Okay, so we're still working on identifying the pieces that we need to identify to be able to graph a rational function. So far we know how to graph, how to identify vertical asymptotes, horizontal asymptotes, and solutions. The next thing that we need to figure out how to do is how to find holes. So there's really 3 steps for identifying holes. So steps to identify holes. Now holes, similar to vertical asymptotes, are where the solution doesn't work, but in this case, they're found using the denominator, but they're also found using the numerator. Holes are going to be a point with an open circle when you go to graph, whereas an asymptote is a line. So for holes, we have to find both the x and the y value. With a vertical asymptote, we only want that x equals, or the horizontal, what a y equals value. So our steps here are, first we want to factor the numerator and denominator. I'm still using that abbreviation, n of x and d of x. And then factors that cancel, the canceled factors create holes in your graph. And so we're going to take those factors that cancel, and we're going to set them equal to 0 to find the x value of our hole. So we're going to set canceled factors equal to 0, and that will give us our x coordinate. So this is the x coordinate of the hole. So we've got 2 steps so far. We're going to factor anything that cancels creates a hole, and then you set that canceled factor equal to 0 to solve for the x coordinate. Then you need that y value because a hole is a point. And so you're going to substitute that x value, sub in x value that you found, into the simplified version of the equation. So after you've canceled, into the simplified version of the equation to find the y value of that hole. So similar to the last unit when we were finding the axis of symmetry, and then we plug that in to find our vertex, we're going to figure out what cancels, and then set that x value, plug that into the equation to find our y value of our hole. So we're going to do a couple examples here, just identifying the key information. So for starters, if we've got this first example, and we have f of x is equal to x over x cubed minus x squared minus 2x. And the first thing we want to do is factor, so it looks like we can take a GCF out of the bottom, x squared minus x minus 2, and set that equal. We get x over x minus 2, and x plus 1, because we want 2 factors of -2 that add and give us -1. So this is simplified as much as we can. We factored everything. Step 2 was to cancel. So we canceled the factors that are the same, and that's the x. And we're going to set that factor equal to 0. So this is our x value. This x is equal to 0. If there was x plus 1, you'd set that equal to 0. Whatever cancels, you set equal to 0. So now we need to take that simplified version. Remember, if you cancel something, there's not a 0 on top, there's a 1. And that's going to help us find our y value. So 1 over x minus 2, x minus 1. And we're taking this 0 and plugging it in for both x's, so that we can find the y value of our hole. And so we have 1 over 0 minus 2 times 0 minus 1, which gives us 1 over -2 times -1, gives us positive 2. So this is the y value of our hole. So our hole can be written as an ordered pair with 0, 1/2 being that point. Now we can still identify the vertical asymptote, horizontal asymptote, and solutions as well, if there's any. In this case, our vertical asymptote, there would be 2 of them. That's what's left over. So there's x equals 2 and x equals -1. So our vertical asymptote is going to be x equals 2 and x equals -1. This equation is bottom heavy, so that means that our horizontal asymptote is going to be y equals 0. And there's nothing left in the numerator after we cancel. We only have the value of 1, so there's nothing we can solve in this case. So that means that we actually have no solutions for this. So no solutions. Now this should hopefully make sense, because if you have an asymptote at 0, your graph most of the time, say 90% of the time, isn't going to cross through that x-axis because you have an asymptote there. Now we do have an exception to that, and we'll get into that a little bit later. Let's do another example. So next example, we've got f of x is equal to x minus 4 over -4. I'm trying to factor before I'm done. -4x squared plus 8x plus 32. And so we want to factor this, factor that denominator. We can take out a -4. So the top's just x minus 4. Take out a -4 here, and we're left with x squared minus 2x minus 8. And so we'll factor that. X minus 4 on the top, -4 on the outside. And we get x minus 4 and x plus 2. And so what cancels here is the x minus 4. So that is the factor that's going to give us our whole. So our whole is going to have an x value of 4, because we set that equal to 0. X minus 4 equal to 0 gives us x equals 4. And now we're going to plug our x value of 4 back into our equation. So we have 1 over -4 times x plus 2. So in 4x is going to be 4. So we're going to put that in there. And so we'll end up with 1 over -4 times 4 plus 2 is 6. So -1/24. Kind of an odd fraction, but you are plugging this value into a fraction, so hopefully that makes sense. So our point here is at -1/24. All right, so there's our whole, and we'll still find our other pieces of information. So we need our vertical asymptote. That's what's left over. The denominator there only had the x plus 2 left. So our vertical asymptote is at x equals -2. Our horizontal asymptote, this was bottom heavy. So automatically going to be y equals 0. And again, nothing left in the numerator, so we have no solutions. Again, hopefully that makes sense, because you have an asymptote at y equals 0, so you're not going to cross the x-axis at all. All right. I'll leave you one to do on your own. So the one I want you to do on your own, here we've got f of x is equal to x squared minus 5x plus 4 and -2x squared plus 18. So we're going to solve this one. First off, see if anything cancels. Maybe something does, maybe something doesn't. Still find your vertical asymptote and your horizontal asymptote and your solutions if necessary. So after factor, you do realize that nothing actually cancels here, so we don't have a hole in here. It's okay to have no hole. We are going to have our two vertical asymptotes at x equals 3 and x equals -3. We're going to have a horizontal asymptote. This is equal heavy with the degree of 2 for both the numerator and denominator. So our equation becomes y equals -1/2. And then our solutions are that numerator, so we'll have two solutions for this one, at 4, 0, and at 1, 0. Have two solutions there.